The National Electrical Code, specifically Section 225.30A4, states that disconnects for all ungrounded conductors at a service entrance must be grouped at one accessible location unless specifically permitted in other sections. Additionally, Section 230.94B1 addresses service disconnecting means for buildings with multiple occupancies, requiring them to be grouped at one accessible location. In the given scenario, the homeowner plans to have multiple occupants, himself and a future shop tenant, which triggers the requirement for grouping the disconnects, even if they are mounted outside the building. Although different authorities having jurisdiction, or ODs, may have differing interpretations of the NEC, it's always best to consult with the local AHJ to determine their specific requirements. To avoid confusion and potential issues, grouping the disconnects is recommended, even if an AHJ says it is not required. This ensures easy accessibility during emergencies. If you do not want to mount the CT can and meter base on the outside of the pump house, consider these options. Firstly, mount the equipment on a pole, as suggested by the second AHJ. Secondly, install the equipment inside the house and run the feeders underground to the pump house and shop. Applying the NEC requirements involves several considerations. Firstly, the service entrance. This is the point where electrical power enters the building. The NEC mandates a disconnecting means at or near the point of entry to isolate the entire electrical system in case of emergencies or maintenance. Secondly, the disconnecting means. These are devices like circuit breakers or fuse switches that can cut off the power supply. Grouping these disconnects ensures that all power sources can be quickly and safely shut down from one location. Thirdly, the multiple occupancies. This refers to situations where a building houses more than one independent unit or tenant. The presence of multiple occupancies increases the complexity of the electrical system and necessitates stricter safety measures, hence the grouping requirement. Fourthly, accessible location. The grouped disconnects must be readily accessible to both occupants and emergency responders. This means they should not be obstructed or located in locked or hard-to-reach areas. Fifthly, AHJ interpretation. While the NEC provides a baseline standard, local AHJ have the authority to interpret and enforce the code based on specific local conditions and practices. Their interpretations can vary, making it crucial to consult with them directly. Now let's delve deeper into the technical aspects of the equipment involved. Consider the CT can. A CT can, or current transformer cabinet, houses current transformers that measure the electrical current flowing through the service conductors. These transformers provide readings to the meter, which then calculates the amount of electricity consumed. The CT can is typically installed before the meter to accurately measure the total current being used by the building. Next, consider the meter base. The meter base is the housing that holds the electrical meter. It's designed to provide a secure and weatherproof enclosure for the meter while allowing easy access for meter reading and maintenance. The meter base is connected to the CT can and the service entrance conductors to measure and record the electrical consumption. Circuit breakers and fuse switches are essential components of the electrical system, serving as disconnecting means. Circuit breakers are electromechanical devices that automatically interrupt the flow of current when an overload or short circuit occurs. They can be reset after the fault is cleared. Fuse switches, on the other hand, use fuses, which are sacrificial devices that melt and break the circuit when the current exceeds a certain level. Fuses must be replaced after they blow. Feeder conductors are the wires that carry electrical power from the service entrance to the various branch circuits throughout the building. They are sized according to the load they are expected to carry, and they must be protected by overcurrent devices, such as circuit breakers or fuses. Understanding the NEC requirements for grounding is also crucial. Grounding is the process of connecting the electrical system to the earth to provide a low impedance path for fault currents. This helps to prevent electrical shock and equipment damage. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the service panel. Different mounting options affect accessibility and safety. Mounting the equipment on a pole provides a dedicated location for the service entrance separate from the building structure. This can simplify the grouping of disconnects and improve accessibility for maintenance and emergency responders. Installing the equipment inside the house requires careful planning to ensure proper clearances and ventilation. The service panel must be readily accessible and should not be located in areas where it could be exposed to moisture or physical damage. Running feeders underground offers aesthetic and safety advantages by concealing the wires and protecting them from the elements. However, underground installations require careful trenching and backfilling to prevent damage to the conductors. Remember to consider the impact of future expansion. Planning for future expansion, such as adding a shop, is essential to ensure that the electrical system can accommodate the additional load. This may involve upsizing the service entrance conductors, installing a larger CT can, and providing additional breaker spaces in the service panel. Always consult with the local AHJ. Consulting with the local AHJ early in the planning process is crucial to ensure compliance with all applicable codes and regulations. The AHJ can provide guidance on specific requirements and interpretations, and they can help to avoid costly mistakes and delays. In practical terms, consider a new house with a 400 amp service. The homeowner wants to install a 400 amp CT can and meter base on the outside of his pump house. From the CT can, he plans to feed two 200 amp main breaker panels inside his house and a 60 amp main breaker panel in the pump house. He also intends to feed a shop in the future. According to the NEC, all disconnects must be grouped at one accessible location, even if they are mounted outside the building. This means that the disconnects for the two 200 amp panels, the 60 amp panel, and the future shop must all be located together, typically in a service panel near the meter. If the homeowner does not want to group the disconnects on the outside of the pump house, he has two options. Firstly, he can mount the CT can and meter base on a pole, separate from the pump house. Secondly, he can install the equipment inside the house and run the feeders underground to the pump house and shop. Here are some additional considerations. Firstly, conductor sizing. The feeder conductors must be sized to carry the expected load, taking into account factors such as voltage drop and ambient temperature. Consult the NEC tables for appropriate conductor sizes. Secondly, overcurrent protection. Each feeder conductor must be protected by an overcurrent device such as the circuit breaker or fuse, sized to protect the conductor from overload and short circuit. Thirdly, grounding. The grounding system must be properly installed to provide a low impedance path for fault currents. This typically involves connecting a grounding electrode to the service panel and bonding all metallic enclosures. Fourthly, labeling. All disconnects and panels must be clearly labeled to indicate their function and the loads they serve. This helps to prevent confusion and ensures that the correct disconnect is opened in an emergency. Fifthly, documentation. Keep detailed records of all electrical work, including wiring diagrams, panel schedules, and inspection reports. This documentation can be valuable for future maintenance and troubleshooting. Now let's talk about specific NEC articles and their relevance. NEC Article 225 covers outside branch circuits and feeders. This article provides requirements for the installation of conductors and equipment located outside the building, including clearance requirements, support methods, and overcurrent protection. NEC Article 230 covers services. This article provides requirements for the installation of service conductors and equipment, including service entrance conductors, service disconnecting means, and grounding. NEC Article 250 covers grounding and bonding. This article provides requirements for the grounding of electrical systems and equipment to ensure safety and prevent electrical shock. NEC Article 310 covers conductors for general wiring. This article provides requirements for the sizing and installation of conductors, including ampacity ratings, temperature ratings, and dirting factors. Understanding these articles is crucial for ensuring compliance with the NEC and for designing a safe and reliable electrical system. Let's consider some common mistakes to avoid. Firstly, undersized conductors. Using conductors that are too small for the load they are expected to carry can result in overheating, voltage drop, and even fire. Always consult the NEC tables for appropriate conductor sizes. Secondly, improper overcurrent protection. Using overcurrent devices that are too large or too small can create a safety hazard. Overcurrent devices should be sized to protect the conductors from overload and short circuit. Thirdly, inadequate grounding. Improper grounding can result in electrical shock and equipment damage. The grounding system must be properly installed and maintained. Fourthly, unlabeled disconnect. Failure to label disconnects can cause confusion and delay in an emergency. All disconnects should be clearly labeled to indicate their function and the loads they serve. Fifthly, lack of documentation. Failure to keep detailed records of electrical work can make future maintenance and troubleshooting difficult. Always maintain accurate wiring diagrams, panel schedules, and inspection reports. Let's explore the role of technology in modern electrical systems. Smart meters are becoming increasingly common. Smart meters provide real-time data on energy consumption, allowing homeowners and utilities to monitor and manage energy use more effectively. They can also be used to detect power outages and other electrical problems. Smart panels are also emerging. Smart panels offer advanced features such as remote monitoring, energy management, and surge protection. They can also provide alerts when electrical problems are detected. Energy storage systems are becoming more popular. Energy storage systems, such as batteries, can store excess energy generated by solar panels or other renewable sources. This energy can then be used to power the home during periods of peak demand or during power outages. Electric vehicle charging stations are a growing necessity. As electric vehicles become more common, the demand for charging stations is increasing. Charging stations can be installed at home or in public places, and they require careful planning to ensure adequate power supply and safety. Renewable energy integration is a key aspect. Integrating renewable energy sources, such as solar panels and wind turbines, into the electrical system requires careful planning and coordination. The NEC provides specific requirements for the installation of renewable energy systems. Consider the importance of regular maintenance and inspection. Regular maintenance and inspection are essential for ensuring the safety and reliability of the electrical system. This includes checking for loose connections, damaged wiring, and corroded components. A qualified electrician should perform regular inspections to identify and address potential problems before they become serious. Discuss the future trends in electrical safety. As technology continues to advance, electrical safety practices must evolve to keep pace. Future trends in electrical safety include the use of arc fault circuit interrupters SI and ground fault circuit interrupters GFCI to protect against electrical shock and fire. The development of new materials and technologies for electrical wiring and equipment is also improving safety. The NEC is constantly being updated to reflect these advancements. To summarize, understanding and applying the NEC requirements for grouping disconnects in multiple building scenarios is crucial for ensuring electrical safety and compliance. Consulting with the local AHJ, considering different mounting options, and planning for future expansion are all essential steps in the process. By following these guidelines and staying up to date on the latest technologies and safety practices, you can help to create a safe and reliable electrical system for your home or business. This information is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work. Additionally, always verify codes and local requirements as they are subject to change based on the local authority having jurisdiction. When determining the conductor ampacity, use Table 310.16. Consider the terminal limitations per section 110.14. C. When running underground, use Article 310.15 for wet locations. Use a copper or other approved conductor for grounding. Section 250.66. A. Specifies the size of the grounding electrode conductor. Using a ground ring is described in Section 250.52. A4. This should not substitute for professional advice, as codes and standards may have changed since this answer. When using PVC conduit, use Schedule 40 or Schedule 80 as appropriate. Consider the ambient temperature and its effect on conductor ampacity. Use 310.15. B1. For ambient temperature correction factors. For conductor dating due to the number of current-carrying conductors in a raceway or cable, consult Table 310.15. C1. Review 230.42. B. For ungrounded conductor sizing for services and feeders. Also note that aluminum conductors have different ampacities compared to copper conductors. Always refer to the NEC tables for the specific conductor type being used. When calculating voltage drop, use the formula specified in Chapter 9, Informational Note Number 2. Pay attention to the continuous load calculations, which require the overcurrent device to be rated at 125% of the continuous load per 210.20. IN 215.3. I. For proper torque, follow the requirements in 110.14. D. Check that all the boxes are properly sized by using Chapter 9 Table 314.16. A. For box fill calculations. Make sure all equipment is listed and labeled by a nationally recognized testing laboratory like UL. Understand the arc flash hazard and use appropriate personal protective equipment when working on energized equipment. Consult an FPA 70. E. For requirements. Use a properly rated meter to verify the absence of voltage before working on any electrical circuit. Do not work alone and always have someone nearby who can assist in case of an emergency. Be aware of the dangers of electricity and take all necessary precautions to prevent electrical shock and burns. For outdoor installations, use weather-rated enclosures and fittings to protect against moisture and corrosion. Follow the manufacturer's instructions for all electrical equipment. When working on existing electrical systems, identify and disconnect all power sources before beginning work. Double-check that the power is off before touching any wires or components. Be careful not to damage existing wiring when installing new equipment. Use appropriate tools and techniques to avoid damaging insulation and conductors. Properly support and secure all wiring and equipment to prevent strain and movement. Avoid overloading circuits. Distribute the load evenly across all available circuits. Use a circuit tracer to identify circuits and locate wiring. This can be helpful when working on existing electrical systems. When in doubt, consult with a qualified electrician. It is always better to be safe than sorry when working with electricity. Always keep your work area clean and organized. This will help to prevent accidents and ensure that the job is done correctly. Dispose of all waste materials properly. Do not leave any loose wires or debris behind.